periodic table that we know today was developed by Dmitri Mendeleev in the 1800s, and he developed this periodic table based on atomic weights. As he organized the table in rows, a pattern started to form, and if you left blanks in the table, he noticed that elements with similar chemical properties occur in vertical columns on the table. So for the rest of this video, we're going to talk about these similarities that he saw. We call the horizontal rows on the periodic table periods, and the vertical columns groups or families. So you can see here that we have 7 rows or 7 periods on our periodic table. So the periods are the rows that go horizontally across. At this time, label the periodic table in your packet in the same way. Here you can see our columns or groups on the periodic table. So we start with 1A, 2A, jump across the canyon here, and 3A, 4A, 5A, 6A, 7A, and 8A. Label the columns on the periodic table in your packet. The periodic table is also organized into metals, nonmetals, and semiconductors, or metalloids. At this time, label metals, nonmetals, and metalloids on your periodic table. Remember that valence electrons are those electrons found in the outermost orbital. This number corresponds to the number of electrons a particular element wants to accept or give away. Elements want to be stable. Stable elements have 8 electrons in their outermost shell. This is called the octet rule. The first group we'll talk about is the alkali metals. Label the alkali metals on your periodic table. The alkali metals are found in group 1 of the periodic table, and they're highly reactive metals. They do not occur freely in nature. These metals only have 1 electron in their outer shell, and you can verify this using a Hotel diagram or a Bohr model. Therefore, they are ready to lose 1 electron in ionic bonding with other elements. As with all metals, alkali metals are malleable, ductile, and are good conductors of heat and electricity. The alkali metals are softer than most other metals. Moving 1 column to the right, we have our alkaline earth metals. So at this time, label the alkaline earth metals on the periodic table in your packet. The alkaline earth metals are found in group 2A, and they have 2 valence electrons. They're metallic, and they have an oxidation number of +2, making them very reactive. Because they have 2 valence electrons, they are looking to fill their octet by losing those 2 electrons. If you were to draw a Bohr model, it would verify this. Next, we have a group that we just call the other metals. Label the other metals on your periodic table in your packet. The other metals are found in groups 3A through 3,5. All elements in column 3A have 3 valence electrons. The elements in column 4A have 4 valence electrons, and the elements in column 5A have 5 valence electrons. While these elements are ductile and malleable, they are not the same as the transition elements. These elements, unlike the transition elements, do not exhibit variable oxidation states, and their valence electrons are only present in their outer shell. All of these elements are solid, have a relatively high density, and are opaque. They have oxidation numbers of +3, ±4, and -3. Next we have the chalcogens located in column 6A. So at this time, label the chalcogens on your periodic table in your packet. The chalcogens are located in group 6A, and all of them have 6 valence electrons. This family consists of the elements oxygen, sulfur, selenium, and tellurium, and the radioactive polonium. Next we have the halogens in column 7A. Label the halogens on your periodic table. The halogens are found in group 7A, and they all have 7 valence electrons. It is composed of 5 nonmetallic elements, and because they have 7 valence electrons, they all have an oxidation number of -1. In column 8A, we have our noble gases, so label this family on your periodic table in your packet. The noble gases are found in group 8A, so they all have 8 valence electrons, making them very stable. This prevents them from forming compounds readily. It also means that they have an oxidation number of 0. Next we have our rare earth elements, the lanthanides and actinides. Label these on your periodic table. The 30 rare earth elements are composed of the lanthanide and actinide series. One element of the lanthanide series and most of the elements of the actinide series are synthetic, which means they're human-made. All of the rare earth metals are found in group 3 of the periodic table and the 6th and 7th periods. In groups 3B through 8B, you'll find the transition metals. Label those on your periodic table in your packet. The 38 elements in group 3B through 8B of the periodic table are called the transition metals. As with all metals, the transition elements are both ductile and malleable and conduct electricity and heat. Their valence electrons are present in more than one shell, and this is why they are often exhibiting several common oxidation states. Here you'll see the semiconductors, or what we call metalloids, on the periodic table. Label these in your packet. Metalloids can be found in groups 3A through 7A, and they function as a boundary that distinguishes metals from nonmetals. They have properties of both metals and nonmetals, and some metalloids, such as silicon and germanium, are semiconductors of electricity. Because elements are sorted by the reactivity due to valence electron group availability, we can state the oxidation number, or the charges, as ions for each group. Label the charges on your periodic table in your packet. Remember that ions are charged particles, and we call a negatively charged ion an anion, which means it has gained electrons, making it more negative, so it has a negative charge. When an ion is positively charged, we call it a cation. This is an atom that has lost electrons, making it less negative, so it has a positive charge.